So I hope now you can hear me, no? I'm sorry, I have just explained it. Okay. So can you hear me now? Okay, thank you. Anyway, thank you for your feedback. Okay. Okay. So now I will do this question by myself. Okay. Still I didn't get any answers from you. Okay. So it is okay, but if you couldn't do this with yourself, okay, now please take a pen and a piece of paper and try to do this with me. Okay, please do this with me. Okay, so I will get the first signal first. Okay, so I will get this signal first. It is xt equal cos 105t plus 5 by 2. Okay, so this is our signal. Okay, so this is actually sinusoidal signal, no? So this is a sinusoidal signal. It is a sinusoidal signal. We know that. So any cos or sine signal is a sinusoidal signal. Sinusoidal signal. Okay. So this is the default representation of a sinusoidal signal. A cos 25 ft plus 5. Okay. So you know that this A is amplitude, this 25f. Okay, so this term related with the frequency. Okay, actually this f is the frequency. Okay, so this is the frequency. Okay, so if you multiply it by this f by 25, you will get omega, the angular frequency. Okay, so this term is equal to actually omega. Okay, so you can also tell this signal as omega t plus 5. Okay, that is the same. There is no different. Okay, so this omega is the angular frequency and this 5 is the frequency. Okay, so this is 25f is equal omega. Okay, so this is the normal representation of a sinusoidal signal. Okay, so are you all familiar with this representation? This sinusoidal representation, do you have any problem here? Okay, do you have any problem here? So if you are given a sinusoidal signal, can you find the frequency? Can you find the omega? Can you find the phase shift? Can you find the fundamental period? So fundamental period is nothing but, so in one way we can say it is equal 1 by f, or we can say it is equal to 5 by omega. Okay, so are you all familiar with this? So still you have doubt, or still do you have any doubts here? Anything that you couldn't understand? Because very often we are using the sinusoidal signals, no? Can you feedback? Are you okay with this representation, this sinusoidal signal representation? Okay, okay, no? Yeah, okay, thank you. So, okay, let's proceed. Okay. So here we are given a sinusoidal signal. Okay, now you can see that the amplitude here is 1. Okay, so amplitude should be 1. Okay, and this is your frequency component. Okay, so this is your frequency component. So what is this actually? This 105, what equal to what? This 105 equal to omega, your angular frequency, no? It is the angular frequency. Angular frequency. So here you are given the angular frequency. And also using this angular frequency, you can find the T naught. Okay. And you can also find the F. Okay, T naught is fundamental period. The fundamental period is nothing by 25 by omega. That means 25 by 105. Okay, so this is your fundamental period. And if you want to find F, what is F? So you know that 25F is equal to omega. So F is equal to omega by 25. That is, the omega is 105 divided by 25. Okay. So these things you should be You should be familiar with this type of representation, this type of value. Okay. Okay. So this is your phase shift. This is the phase shift. Okay. The phase shift is 5/2. Okay. Now you are asked to represent, you are asked to find the complex exponential Fourier series representation of this signal xt. Okay, so how do you find? How do you find? Can you suggest any method? What is the what uh, what formula we are going to use? We have used this many times. What formula? We no need to go through this in our principal approach, no? If you have a cosine or sine terms, okay, we no need to go through our principal approach. Okay, what can we do? Okay, what can we do? Tell me. Please tell. We can use Euler formula. Yes, thank you. Okay, very good. Okay, so we can use Euler formula. Okay, so you know the Euler formula. Okay, so Euler formula is this: Ej theta is equal to cos theta. Okay, cos theta j theta equal cos theta plus j sin theta. Okay, and E minus j theta is equal to cos theta minus j sin theta. So these are the Euler formulas. Okay, so using these Euler formulas, we can represent any sinusoidal signal as a complex exponential terms. Okay, so if you add these 1 and 2, okay, if you add these 1 and 2, you will have 2 cos theta. So cos theta plus cos theta, that is 2 cos theta, is equal to a j theta plus e minus j theta. Okay, so you have 2 cos theta is equal to e j theta plus e minus j theta. Okay, and so you want, if you want to find the cos theta, so both sides you can divide it by 2. You can divide both sides by 2. Okay, so you have so I will write like this: e half e j theta plus half e minus j theta. Correct. So I think this also okay for you. Okay, this also okay for you. Okay. So if I write this signal cos 105t plus 5 by t, so the xt is, okay, so xt is cos 105t plus 5 by 2. Okay, so this is the signal. Okay, so this is actually theta. Okay, so this all terms is just like theta. Okay, so this whole term is equal to theta here. Okay, because that is the that is the angle, no? So this is the angle. Okay, so this whole terms 105t plus 5 by 2 is equal to theta. Okay, if we compare it with this equation, with this one. Okay, so we can write this as xt plus half e. So here j theta means this one. So we have j, okay, 105t plus 5 by 2, okay, plus half e to the power minus j, the theta is 105t plus 5 by 2. I hope this one also okay for you. Are there any problem with this? Okay, Are there any problem with this? Did you all get it? How we come to this stage? Are there any questions? Okay. Okay. So I think this step is clear, all of you. Okay. So now we are going to do some changes. Okay, we are going to do some changes. Actually, now you can see that. So we have write this xt. We have write this xt as a exponential terms. No, so we have already wrote this xt as a complex exponential terms. Okay, complex exponential terms. Okay, but we can further simplify this. Okay, so you can see that this is j 105t plus j 5 by 2. Okay, so so here is a plus. Okay, plus value. Okay, so you can write this as a product. No, okay, like this, half e to the power j 5 by 2 e to the power j 105t. Correct. We can also write like this term. Okay, because you know that if we have ax plus y, okay, then we can write this as ax ay. Okay, ax divided by ax multiplied by ay. Okay, okay, so these are some uh, basic algebraic, no? Okay, so I think this point is also clear for you. Okay, අපි දර්ශක කියලා ඉගෙන ගන්න. මම දන්නේ ඉංග්‍රීසි වචනේ. If anyone know the English word, you can tell. Okay, it is power or something maybe. Okay, so in Sinhala it is called darshaka, no? So there are some darshaka rules. Okay, if you have two power with the same foot, okay, and if you multiply that, okay, so you can add these two power. That is the first rule, I think. Okay, so if you divide it, the power should be subtract. Okay, that is the second rule. Okay, so there are, I think, 3 or 5 rules related with this. Okay, so I think this also okay, clear for you. Okay, and also we can say in the same manner we can write this term also. So you can write this as e minus j. So here 5 by 2 e minus j 105 like this. Okay, so can anyone tell why I write these terms, why I get this term in front? Can anyone tell me? Can anyone tell me? Actually, I get this term in front because this term has t. Okay, this term has the t. Okay, so this t is a variable, no? So this is the variable, the time is t, independent variable. Okay, so this terms has no any t. Okay, so that means these are constant. Okay, so all this term is a constant, and this one also a constant. Okay. Okay, so that is why I take this e to the power j5t in front. Okay, so I hope this is okay. This stage is okay. This step also clear, all of you. Okay, so then okay, now so now so already we have already wrote this xt in terms of exponential terms, no? In terms of exponential terms. Okay, So these are coefficients actually. So these are constant. Okay. So these are the coefficients. Okay. These are the coefficients, and this will be the exponential terms. Okay. Okay. Then how to find the coefficients? Coefficients number. Coefficients number. How to find the coefficients number? How to find the coefficients number? Actually, so you have to write these terms in term of. So I think we have done this. Okay, so you have to write this term in terms of omega naught t. Okay, omega naught in terms of omega naught. Okay, so what is the omega naught here? What is the fundamental frequency here for this signal? What is the fundamental frequency for this signal omega naught? What is that? Can anyone tell me? What is the omega naught? That is very simple. I think you all should know the answer for this. That is very simple. Okay, I need the answer. What is omega naught? No, that is not the omega naught. What is omega naught? This is the omega naught, no? This is the omega naught. So this is your frequency. This is the omega naught. Omega naught is 105. Okay. If you want to find the fundamental period, what is that? It is 25 by omega naught. That means 25 by 105. I think I have tell it. I have told here. So here I have told you. No. So I have already told you. This P naught and this will be our omega naught. That is 105. Okay. Okay. So this will be your omega naught. So this will be your omega naught, and in this case also, and this case also. Okay. So I can write this signal again as, okay, I will write this signal as half e to the power j 5 by 2. Okay. So we have e to the power j 105. Okay. So that is omega naught. Omega naught. And here we have t. Okay. Plus half e minus j 5 by 2. Okay. So here there is no half. Okay. Because I already write this half here. Okay. So there is no half. It is a mistake. Okay. So here I have e to the power minus j 5 by 2. Okay. And we have coefficients. What is that? E to the power minus j omega naught t. So, okay. So this omega naught is 105. Okay. 105. Okay. So what is the k value here? So you know that if you find the k here, it is just like this, e j k omega naught t. Okay. So you have omega naught, you have t, and you have j. So what is the k here? K. What is the k value for this? What is the coefficients number? Harmonic number. That k is a harmonic number, no? What is that? Tell me. Please tell me. It is okay. If your answers are wrong, that is okay. Okay. So what do you think? What is the k? Tell me your answer. If it is wrong, I am not going to blame or I'm not going to do anything. Okay? It is, there is no any impact. Please tell me. What is the k value? What is the k here? K for this. So here J, so if you write this in terms of omega, you will get E J K omega naught T. Likewise, okay. So here you have omega 105, here you have T, and here you have J. Okay, so what is the K value? That is, if you find the K value, what is that? What is the K value? So you know that, okay. So I think still you couldn't understand this, okay, because this is very simple, okay. So you are given a xt signal, okay. So you are given xt signal, and you are asked to find the Fourier series representation. You are asked to find the Fourier series representation for this signal, complex exponential Fourier series representation. Then how can we find it? Okay, so we know that xt can be written as a sum of, okay, sum of e terms, okay, e terms j omega naught t k and a k, and this k from minus infinity to plus infinity, okay. So we can estimate this ak by integral, okay. So we have to get 1 by t, we have to integrate it within t, that means the fundamental period, okay. So these are periodic signal, okay. So xt is a periodic signal, okay. And we can get xt e to the power minus j k omega naught t. So using this, you can find the AK values. Okay, and you know that for A naught, we have to evaluate it separately. So you will have this one. Okay, so this is the Fourier series representation. Okay, so if I write this, okay, uh, okay,